Section 9.1 is on graphing quadratic functions. A quadratic function is a function of the form y equals ax squared plus bx plus c, where a is not equal to 0. And this form should look familiar to you, the ax squared plus bx plus c, because in the last chapter we spent a lot of time factoring quadratic expressions that looked like this. The graph of a quadratic function is a parabola, and that's what I've drawn here in blue. It is symmetric about a vertical line that is called the axis of symmetry, and that is this pink line that I've dashed right here. To find the equation of the axis of symmetry, it's equal to x equals negative b over 2a. So for this equation, a would be 1 and b would be 4, and you just plug those into the equation. The y-intercept of the graph is whatever c is. So let's take a look at this. So I already pointed out the pink axis of symmetry, and so then that's x equals negative 2, because if I plugged in 4 for b and 1 for a, that's what I would get here. The y-intercept is my c value of 1, so right there in green that's 1. And the vertex is this point down here, and that's the ordered pair negative 2, negative 3. You'll notice that the axis of symmetry passes through the vertex, so that means that the x-coordinate of the vertex is also negative b over 2a. Then to find the y-coordinate of the vertex, you plug this x value into the function and it'll give you the y. If a is a positive number, that is if a is greater than 0, the graph opens upward and the y of the vertex is a minimum value, and that would look like this graph right here on the left. If a is negative, or a is less than 0, the graph opens downward and the y of the vertex is a maximum value, and that's this graph right here. The vertex is a maximum. So let's take a look at several examples here. So for this graph, find the vertex, the equation of the axis of symmetry, and the y-intercept. So the vertex is going to be this point right here. And from the graph, I can read that that's the point 1, 2. The equation of the axis of symmetry is going to be this line that goes through the graph, goes right through the vertex, and it's symmetric about that. And the equation of that line is x equals 1. Don't just write 1, it's an equation of a line, so it has to be x equals 1, and it is that vertical line. And then the y-intercept is this point right here where the graph crosses the y-axis, and that is 3. The y-intercept is 3. Let's take a look at a couple more examples here. Now we're not given a graph, but we're given the equation, we're given the function, and we have to find the vertex, the equation of the axis of symmetry, and the y-intercept. So the first thing I think I would like to do is identify what a, b, and c are. So a is 1, b is negative 4, and c is 5. So to find the vertex, I need to find the x of the vertex, so that's negative b over 2a, or a negative 4 over 2 times 1, which gives me 4 over 2, or 2. So that's going to be the x of the vertex. Now to find the y of the vertex, I need to plug 2 into this equation for x. So 2 squared minus 4 times 2 plus 5 gives me 4 minus 8 plus 5, or a positive 1. So my vertex is the point 2, 1. My axis of symmetry is x equals the x of the vertex, which is 2, and my y-intercept is my c value, so my y-intercept is 5. Let's take a look at the second example here. Y equals negative 3x squared plus 6x minus 1. So a is equal to negative 3, b equals 6, and c equals negative 1. So let's find the x of the vertex. So x equals negative b over 2a, or negative 6 over 2 times negative 3. That gives me negative 6 over negative 6, or 1. Now to find the y, we're going to plug 1 back into this equation. So negative 3 times 1 squared plus 6 times 1 minus 1. That's going to give me negative 3 plus 6 minus 1, or 2. So my vertex is the point 1, 2. My axis of symmetry is x equals whatever the x of the vertex is, and then my y-intercept is my c, which is negative 1. Here's a couple more examples. In these we need to consider each function and first of all determine whether it has a maximum or a minimum value. We need to state that maximum or minimum value and then find the domain and range. Okay, so looking at this, a is equal to 3, and since that is a positive number, that means that my graph is going to open upwards like this, and my vertex is going to be a minimum. Now to find that minimum value, it's the y of the vertex, so I need to find the vertex. So I'll do x equals negative b over 2a, or a negative negative 6 over 2 times 3, which gives me 6 over 6, or 1. So that's the x of my vertex. Now to find the y, I'll plug that in. So 3 times 1 squared minus 6 times 1 minus 3 gives me 3 minus 6 minus 3, or negative 6. So my minimum value is equal to negative 6. Now to find the domain and the range. So the domain is what x can be. So in this case, and actually for all of these quadratic functions, the domain is all real numbers, because x can be anything. Okay, and the range is going to be what the y equals. So I'm going to write the set of all y such that y is, now because my vertex is a minimum and my graph opens upwards, it's going to be a greater than or equal to whatever that minimum value is. So my range is the set of all y such that y is greater than or equal to negative 6. So whatever the y of my vertex is, that's the number that goes in here. Since it opens upward and all of the other y values are going to be greater than that or equal to it, it's going to be greater than or equal to. Let's take a look at second example here. Y equals negative x squared minus 2x plus 2. So in this case my a is negative 1. So that means my graph is going to open downwards like this. My vertex is going to be here. So my vertex is going to be a maximum value. Oops. Okay. And to find that maximum value, again I need to find the y of the vertex. So I need to start by finding the x, negative b over 2a, or a negative 2 over 2 times a, which is negative 1, or 2 over negative 2, or negative 1. Now to find my y, I'll plug negative 1 into this function. So a negative 1 squared minus 2 times negative 1 plus 2. Now be careful here. Make sure you're doing PEMDAS when you evaluate this. Do not do negative 1 and then square it. In PEMDAS, exponents come before multiplying. So this is negative 1 times negative 1 squared. So negative 1 squared is 1 times a negative 1 gives me negative 1. Plus 2 gives me a value of 3. So my maximum value, the maximum value of this function is the y of the vertex, which is 3. Now for the domain and range, again, the domain is all real numbers, as it is for all of these. And my range is the set of all y such that y, now since this is a maximum value and my graph opens downwards, it's going to be a less than or equal to the y value of my vertex, which is 3. So in other words, all of my y values are going to be less than or equal to the y of the vertex, which is 3. And my last example here is I need to graph this function, and I'm going to do this by making a table of values. But to do that, I first want to find out what is my vertex, because I'd like my vertex to be in the center of my table so I get a nice symmetric curve. So I'll do x equals negative b over 2a. If you've been writing that every time, you should have it memorized by now. So that's going to give me negative 4 over 2 times negative 2, which is negative 4 over negative 4, which is 1. And then the y of my vertex, plugging 1 into there, negative 2 times 1 squared, plus 4 times 1, plus 1, gives me 1 squared is 1 times negative 2 is negative 2, plus 4, plus 1, or a y value of 3. So my vertex is the point 1, 3. So now what I want to do with the table of values, well, that's a little sloppy, but anyway, okay, make an x and y column, and I want you to do 5 values, and I want the middle one to be my vertex, which is 1, 3. And now I'm going to choose 2 x's that are smaller, so like 0 and negative 1, and then 2 x's that are larger, so like 2 and 3. And now I plug those in. And I'm going to start with the easiest one, which is 0, because when I plug in 0, this becomes 0, this becomes 0, and I have just 1. Now let's plug in negative 1. So negative 2 times negative 1 squared plus 4 times negative 1 plus 1 gives me a negative 2 minus 4 plus 1, or negative 6 plus 1, or a negative 5. Now let's plug in 2. Negative 2 times 2 squared plus 4 times 2 plus 1. 2 squared is 4 times negative 2 is negative 8 plus 8 plus 1 gives me 1. And now plugging in 3. Gives me 3 squared, which is 9, times 2 is negative 18, plus 12, plus 1, which gives me a negative 5. So let's go ahead and graph those points. So negative 1, negative 5, 0, 0, 1, 1, 3, 2, 1, and 3, negative 5. And it makes sense since my a was a negative 2. It's a negative number, so it's going to open downwards and go like that. Try to give it a little bit of curve when you draw it. I always end up making mine too pointy at the top, but it's not a V. It's actually a curve in there. The other thing you'll notice is that we do have, I'll go ahead and draw it in here, my line of symmetry right here, or my axis of symmetry. Okay, and that's going to be the line x equals 1. And you'll notice that these 2 points are right across from each other, and these 2 points are right across from each other, as they are supposed to be. And then you'll also notice in the table that the y's are symmetric, and they should be. That's what gives you this symmetric curve. So in this lesson, we took a look at how to graph a quadratic function by finding the vertex, the equation of the axis of symmetry, the y-intercept, maximum and minimum values, domain and range, and how to make a table of values.